Good day to all. Today we are going to see about that self-controlled synchronous motor drive with that employing a cycloconverter. See, what is the meaning of cycloconverter? Cycloconverter is nothing but it's convert AC to AC. Converts the AC signal to AC, which is increasing in the frequency or depending upon our application. The frequency will change with the cycloconverter without any DC links over here. So you can see here the free three-phase supply is given to that cycloconverter, and this cycloconverter will have a synchronous motor. As we know already, synchronous motor is have a synchronous speed. In that synchronous motor you have no more number of speed, as well as it is own the speed is reduced. It has a synchronous speed. This synchronous speed motor will connected with that rotor position. From that synchronous motor, the rotor will rotates and it will give the output to the control circuit of cycloconverter. This control circuit will controlled by the external control voltage. How much frequency you have to change in that particular converter we will give here in that controller. So again it will go for cycloconverter. With this type we will have the increase or decrease in the frequency of this synchronous motor employing the cycloconverter. Then see closed loop of load commutator inverter type. Here you will see the load side converter is here and source side converter also here, motor and terminal voltage sensor and phase delay, firing circuit, current control and firing circuit is there, and speed control is there, current limiter is there, and the sign of E omega m is also there. Here the AC supply is given to that source side converter, and it will have connected with that inductor. In that inductor the current ID will pass over here, then it will connect to load side converter. The output of this circuit is the motor. Here what will happen, we will get the terminal voltage phase sensor. Here we have a pulse. After this terminal we will have a pulse over here. This pulse will have some frequency. This frequency will set through this phase delay, phase of terminal voltage, without changing any frequency. After the pulse will come out from this particular terminal voltage sensor, it won't get any frequency change and it will go to the phase supply. After that firing circuit, the pulse will have a commutated pulse will generate here after that firing circuit. Then it will move to the load side converter. Here it is the omega m is called speed error. Here if it is the speed error is increase, this omega m increase will have a sign, some sign over here. If it is omega m is decrease, the same, the different sign over here. So depending upon this omega m increase or decrease, will have a sign of this sign E omega m. That we will see over here. If there is a increase in that speed, here in Wm is increase, the speed error is increase, means here it will come over here, the sign E omega m will have a positive sign over here, because of here the speed is increased. So this sign omega m will have a positive sign. Then this positive sign will move up to this phase delay. Already we have one pulse with over here. Then this positive sign also will included here. Then it will go for firing circuit. This BLC, beta LC, will give the correct output to the load side converter. Without affecting the motor, it will give the accurate output to that particular load side converter over here. So it is for that if the speed is increasing, then the same time here the speed controller, here it is used for speed controller, and after that there is a current limiter which has that ID. Here the DC voltage come over here, and this current limiter shouldn't cross the over limit of particular current. If the current is over limited, it will limited to that, or it will stable to that particular speed of that current. The current won't be get increased more or decreased more. It will make as a stable stage 1. This is for the increasing in that speed error. If it is a decrease here, this Wm is decreased here, what will happen? If the decreasing current will come over here and it will come over here, now this sign E omega m will have a negative sign, whereas if it is increase in the W omega m, what we had for positive. Now if it is negative, Wm is negative, then we'll have a negative sign because of this Wm is decreasing the speed error. If it is omega m is increased, we'll have a positive sign over here. So if it is speed error is negative, this sign will move up to that phase delay, and then it move on to firing circuit. Here this beta LC will have an operation according to that particular sign of the speed error. Then here the DC controller, speed controller and current limiter will have a same procedure. Take care for that when the speed error is in positive. So after that the current will pass over here. This speed controller will control the speed. It won't be get more decrease in that speed, as well as the current limiter is also be it just used to limit the current. It won't be get over speed, as well as we'll see it won't be get give a more current. As I said before, for increasing the Wm also, this current limiter limits the current, as well as here also now it's a W, the omega m is a decrease also. This same time this current limiter will limit the current according to our applications process. Then this controlling unit will go into that current controlling and firing circuit. Then it will connected with that source side converter, because already we have that AC power supply in that source side converter. After that source side converter only it will move up to that load side converter. So this process will continuous as much as the speed is going to positive as well as negative. Because of that omega m, the sign of E omega m will also change. According to change in the sign E omega m, The BLDC, beta LTC will takes over the place. These are all about that closed loop control of load commutator inverter synchronous. Thank you.